In college algebra, we finished up 4.3 properties of logs. It was either Monday or Tuesday, we got through example 2. So we're going to press on through example 4 and then on to the back. So we're using these 3 properties and we're expanding, so keyword right there, expanding, not evaluating. We're not typing them into the calculator. We're not using a calculator at all, actually. We're just rewriting something like this to something like this, or like that, or like that. And some of these apply all 3 properties. So on number 3, we have an exponent in 3a right here, and according to that power rule at the top of the page, we can rewrite this as log 5, 7. And that's all I'm asking you to do on a problem like this. On 3b, it uses a concept that we talked about a long time ago. We had an exponent lesson, and we talked about how this right here really has a 1 right here and a 2 right there, right? Because it's square root of x. So you can write that with an exponent, 1/2, which is what question 3b is asking you to look at. So we rewrite this thing as this, and that exponent can get thrown on the front, and it becomes 1/2 ln x. All right, number 4, it gets a lot more involved. We're going to use multiple properties on one problem. On 4a, I see some multiplying going on between x squared and square root of y. So I'm going to separate into 2 logs. I have log b x squared plus log b square root of y. I can move that squared, that 2 to the front, and I can change that square root of y into y to the 1/2. And then on the last line, I can move the 1/2 to the front. And that's all you do. All right, this one's ugly. There's a lot going on. Let's change colors. I see division, I see multiplying, I see exponents. Let's deal with the division first. And by the way, I didn't say it on 4a. You have to undo these logs, expand the logs by doing multiplying and dividing first. So it's almost like you're doing PEMDAS backwards. So you have to deal with the multiplying and division before you deal with exponents. So I'm going to rewrite this as log 6 cube root of x minus the denominator, log 6 36y4. All right. I'm going to rewrite the cube root of x as x to the 1/3. And I can separate the log 6 36y to the 4. So first step, let's change this to x to the 3rd. And then be really careful on this line, because if you separate these with a plus sign, like the property says to do, we actually made a mistake. Because of this minus right here, this whole log is being subtracted. But look down here, I'm subtracting this log but adding that log. That contradicts the previous line. So whenever we see that minus, we got to make sure we put this in parentheses. And then we're safe. All right, let's finish it out. So we can write 1/3 in the front. If you want to rewrite this log that I'm writing right now as just 2, you could, because 6 to the second equals 36, but I'm okay with you leaving it alone. On this last log, move 4 to the front, and you're done. So I am A-okay with that final line. That kind of looks like 41. That says 4 log 6y. All right, let's move to the back. And on the back, we're going in reverse. So instead of expanding, we are condensing. I see a plus, which means I'm going to condense into 1 log, multiplying. So 2 times 32. You could write it log 464. Log 464 actually equals 3. Anytime you get a whole number, you're welcome to just write the whole number for an answer, but I'm fine with just that. On part B over here, I could see people mixing up this part right here. So I can only combine terms if they each have a log. And so that -3, it's attached to the 4x with parentheses. So I can't do any division based on this. But I can do division because of that right there. So I would rewrite this as log 4x minus 3 in the numerator over x. And you can put that in parentheses if you want. You don't, parentheses aren't vital on that one. All right, number 6, it gets a lot more involved. I see front numbers and I see a plus. Front numbers we want to rewrite as an exponent. And if you can do multiple steps at once, you are welcome to. And then I see the plus, also the half I can rewrite. Let's go ahead and deal with the half. Square root of x. And then that plus makes us combine and do multiplying. So final answer, log of square root of x times x minus 1 to the 4th. All right, let's try 6b. That 3 becomes an exponent. And then one more step. This one's not bad at all. And that's it. 6c is the one where it's difficult and I could see someone confidently writing the wrong answer. I'm going to work it up here. Let's deal with the front numbers. That part's easy. So I can rewrite this as log b x to the 4th minus log b 6 to the 2nd plus log b y to the half. Now I got to read this thing left to right because I see minus and plus. They're kind of like a tie. And the correct way to approach a problem with a tie in terms of PEMDAS, minus and plus, is to read it left to right. And if you don't, you'll get the wrong answer. You'll get a totally wrong answer. So let's do the minus first. So the minus implies divide, and I'm going to ignore the plus log b y half. So first step, I get log b x to the 4th over 6 squared. And then that plus log by is still there. So log b, and I'm going to go ahead and change that half to a square root of y. And then last step, I combine that plus into a multiply. So final answer, x to the fourth over 6 squared times square root of y. So that square root of y is not in the denominator. And if you did order of operations wrong, you did the plus first over in the original problem, the y might have ended up in the denominator, which is bad. All right, last thing on this is a simple one. Anytime you see evaluate, just type it in. So when you do that, log 5 140, you get 3.07. So, I mean, you can use natural logs, but you end up having to type it into the calculator anyways. So I think that's kind of a waste. All right. It was also before the Inspire existed. And when you had an old school TI-84, that concept was important. But I'm not going to test that. Just type it in. Y'all have a good day. Bye.